This episode starts Chapter 0. The authors say it is mainly there to be referred back to, but one thing in it must be read: the order of quantifiers. First, the basics. A sentence that is true or false as it stands is a statement. One containing a variable is a statement frame. There are two ways to turn a frame into a statement. One is to give the variable a value. The other is to assert that it is always true by prefixing for every x. That prefix is the universal quantifier. For each x, and for all x, say the same thing. The other way is to assert that it is sometimes true, written there exists an x such that. That is the existential quantifier. A quantified variable is called bound, an unquantified one free. The x is still in the sentence, but it can no longer be given values. Now the most important point in this section. A sentence with two free variables needs two quantifiers, and when quantifiers of both kinds are used, the order in which they are written changes what the sentence says. Here is the book's example. For every x there exists a y with x less than y is true. Take y to be x plus 1. But there exists a y such that for every x is less than y is false, because that y plus 1 is not less than itself. The difference is that in the first the y may change with x, while the second demands a single y that works for every x, which is far stronger. The authors put it bluntly. The reader must be absolutely clear on this point. His whole mathematical future is at stake. Among quantifiers of the same kind, the order does not matter, and they can be abbreviated into one symbol. Convergence and continuity both need three quantifiers. For every error, there is an index beyond which every term is close enough, and continuity has exactly the same shape. Next, the connectives. And is true only when both sides are true, or is used in ordinary speech both exclusively and inclusively. Mathematics cannot tolerate that ambiguity. So in mathematics, or is always inclusive. At least one is true, and possibly both. The troublesome one is if then. Since if x is less than 3, then x is less than 5 holds for every x. We are forced to accept that the whole sentence is true whenever the premise is false. So it is false only when the premise is true and the conclusion false. A form whose truth table is always true is called a tautology, and any valid principle of reasoning not involving quantifiers must be expressed by 1. 3 useful equivalences. Not P or Q is not P and not Q. P implies Q is Q or not P. Not of P implies Q is P and not Q. Finally, negating quantifiers. Not always true means the same as sometimes false, and that lets a negation sign move past a whole string of quantifiers. The practical rule: change each quantifier to the opposite kind, and move the negation sign to the end of the string.